All right, welcome back. Mr. P helps with calculus. This is Unit 2, day number 6. And we're going to get into estimating derivatives in this video. And we're going to do that both using a calculator and using average rate of change. All right, so starting off with this estimations using a calculator. So if you go to math on your calculator, so using your TI-83 Plus or TI-84, or maybe even a TI-89, hopefully you have one with a newer software in it, because the newer software is going to be a lot easier to input. It works a little bit differently than the ones that have the older software. Math 8 is going to say n deriv, meaning finding the derivative of n, meaning any term. And what you're going to do, and hopefully you have the newer software where you can just literally put this equation in, and then it'll ask you for what you want x to be equal to. So there should be an actual x equals down here in the bottom right hand corner. And then you make a -1, and then you just press enter, and it does all the work for you. It tells you that the answer is 5, meaning the slope is 5 when x is -1 of this function. That's literally what that translates to. Now, if you have an older calculator, what you'll end up having to do is you'll press Math 8, then you're going to put this function in, and then you're going to have to press comma x comma -1, and then press enter. And then it'll give you the exact same answer. It's just different ways of inputting. Same thing for this. It's going to give you the exact same thing. So math 8, which should be derivative of, you put the function in, and then you put in your 5. And then, yeah, that's what that means. It means the rate of change, or the slope, is 5. I'm sorry, the rate of change is 1/3 when x is 5 of this function. All right, so now we're looking at tables here, and we're trying to make an estimate. So we're going to estimate what r prime of 2 is, given this table of values. Now, keep in mind, it does say, I should say at least, in the question about it being a continuous function, well, it does say it's differentiable. And that's the key here, because all differentiable functions are continuous. So even though it doesn't say continuous, we now know it is continuous, because it must be, because it says it's differentiable. And that is very important. You do need to understand what those words mean when it comes to AP exam, because that's the way they like to write the questions, different ways. They want to make sure you know that when it says it's differentiable, that it also makes you know that it is also continuous. It's not an assumption. All right, so now r prime of 2 is going to be, I'm going to use the slope format. 2 is in between 1 and 3. What we're essentially going to do is just find the average rate of change. We're going to find, because we don't know really what 2's value is. So we don't really know what the slope is at that point. So what we're going to do is find the average rate of change. So that means the average slope from 1 to 3, and just sort of make an assumption. That's why I'm writing about, because it's not really exactly. It's really just an estimation. We're going to say that if the slope changed from 1 to 3, if it changed by this much, then we're going to say that it was this much the entire time. It was decreasing by 120 for both of those 2 minutes. So it took 1 minute to get the 2 and then another minute to get the 3, which means it should have actually decreased by 240, which it looks like it did. So that's on average per minute. That is the amount of liters per minute. And now it's decreased. And one thing I do want to stretch on the AP exam is when they're asking you to, this is just indicate units of measure, but had it say, explain what it means in the context of the question. I know that's not the question here, but I'm just throwing it out there because you will see that on the AP exam. But when it says, what does that mean in the context of the question, don't ever use negatives in your answer. Make sure you say that it is decreasing by 120 liters per hour per hour. Now, you might be wondering, why am I saying per hour? Because in the question itself, it says R of t is liters of per hour. So if R of t is already a rate, as a matter of fact, it says it right there. If R of t is already a rate, then essentially what we're doing is we're finding an average rate of that rate. So it's not just the liters per hour, it's how much that liters per hour is changing per hour. That's why it's per hour per hour. All right, number 4 is a very similar question. 16 is right in between 12 and 20. It really doesn't matter if it was exactly in between, although it usually will be. But really, we're just finding an average from here to here, so we're assuming the entire time from 12 to 20, it's always the same. Now, this one is also meters per minute. So if V of t is a rate itself, then yes, this is the rate at which that rate is changing. So V prime is 16 actually represents the meters per minute or per minute squared. You can also say that. Now, once again, this question does say differentiable. It is just using the slope formula, so I'm going to let you pretty much make sense of that on your own. It's just y sub 2 minus y sub 1 over x sub 2 minus x sub 1. It's really just finding the average rate of change. All right, same kind of question. 3.5 is in between 3 and 4, so we're really only looking at these numbers. Once again, it's differentiable. Very important. This time it's just ounces. That's a big difference. This is not a rate. This is minutes. This is ounces. So if we're trying to find the rate at 3.5 minutes, then that would be 1.6 ounces per minute, not per minute squared, because it's not the rate of a rate. It's a rate of simple ounces. Very important key factor there. All right, so now looking at a graph is going to be kind of easy. You really only have, and I know you can see all the answers, but there's really only one thing to keep track of. Some of these questions might say prime. Some of these, if it just said f of 5, well, f of 5 is the yellow function. F of 5 would be 2. But that's not the question. The question is f prime of 5, meaning what's the rate of change at 5? This entire piece has the same slope, which happens to be up 1, right 2. Up 1, right 2, up 1, right 2, up 1, right 2. So at 5, the rate of change is 1/2. F prime of 9. Once again, if it just said f of 9, that would be 4. It's not asking for the height at 9. It's asking for what's the slope. And this is kind of an important one. If you remember back to the last video, there's 3 ways that it's not differentiable. It could be a corner, a cusp, or a vertical tangent line. This is a corner, meaning slopes have to change gradually to be differentiable. This slope is changing instantaneously. So that is not a differentiable point right there. That is what we call a corner. So that is DNE, which stands for does not exist. F prime of 2 would be right here. So this entire piece has the same slope of down 1, right 1. And the G primes are pretty much the exact same thing. Only difference is, you know, right here we have 0 slope. This point is 0 slope. So G prime of 3 is 0 slope. This, remember, is a corner. I know it looks like that's on the same ledge, but the 2 corners themselves are not differentiable. All the other places on that function are differentiable. All right, one more. This one, you know what, this is a very similar question. We're trying to find 5.5. We do have to read the question up here. It says T is in degrees Fahrenheit. T, lowercase t is in minutes. So T, capitalized T is not a rate. Very important. So if we're trying to find the rate of larger case t, that's going to be just degrees Fahrenheit per minute. Not per minute, because uppercase T was not a rate itself. It was just the temperature in degrees Fahrenheit. So this is the amount of change of degrees Fahrenheit per minute. Degrees Fahrenheit per minute. Bottom's minutes. Capital T of, okay, I should have capitalized that, but I think we can get past that. Capital T of 6 minus capital T of 5, right? So that's going to be your degrees temperature, change in temperature, and this is your change of time, giving you degrees Fahrenheit per minute. And then the rest you can just use a calculator. All right, use a calculator to approximate. This is very much like what I did at the very beginning. You can literally just put this in the calculator and then evaluate it when x is 7. So I should have put an evaluate down here, x when x equals 7. And then just press enter, and that's it. That's all you got to do until we actually learn the rules for how to differentiate these functions, which we will. This is all you're going to do for right now is just use a calculator. All right, thanks again for watching. I'll see you in the next video.